Okay, let's start at Unit 2 of the mechanics, and what we're going to start with now is position. Position tells me where an object is. So first of all, we need to define where our starting point is. What are we referring to? Where do we say the position is from? Because without that, it doesn't make any sense. So a frame of reference is a set of reference points that enables the position of an object to be defined. So I'm able to say that you are 30 meters in front of me or 20 meters from the left to the left of me, but I'm the reference. So I'm saying you start at me and then you can go in different directions. Okay, so that's what we mean by reference point. So if we look at a boy who's playing in a park, so there's my boy. Okay, he's somewhere between a slide and a set of swings, and I need to be able to tell you to go from one place to another. So in order to do that, we can say if the boy is my starting point, then we can say, well, the swing is to the left, as we're looking at, left 3 meters to the left of the boy. That's easy enough. The slide is 1 meter to the right of the boy, so it's on the other side and it's 1 meter. But if I make the swing my reference point, so now this is where I'm starting, the boy is 3 meters to the right of the swing, but the slide is now 4 meters to the right of the swing, because it's further. If I make the slide my reference, then everything's actually to the left of the swing. So the boy is now 1 meter to the left of the slide, sorry, not the swing. And the swing is 4 meters to the left. So we need to say where we're starting. What's our reference point? Because without the reference point, I could go 3 meters to the right and you don't know what I'm going for. If I say, go to the slide 3 meters left, from where? Okay, you got to have somewhere to start from. Frames of reference. Now, our large and most common frame of reference is the Earth. And we use the Earth as our frame of reference without even realizing it. So you might now be saying, I'm not moving, and relative to the Earth, you're not. But if you could look at yourself from the sun, you actually are moving, because the Earth is spinning and it's moving around the sun. So you are moving. Just relative to the sun, you're moving, but relative to the Earth, you're not. With frames of reference, that's where we can start using north, south, east, west, up, down. Those are the directions, okay? Now, this is a bit of a funny one. When you're waiting at a red light and a bus pulls up, or even a car, sometimes if you're sitting in the car and the car's stationary, it'll feel a little like you're moving backwards when the bus moves past you. If it's going slow, if it's going fast, you don't really notice it. But if it's going quite slow, it can be a little disconcerting, because you're going to feel like you're going backwards, even though you're not actually going backwards. Okay? It's just because relative to the bus, you are going backwards. Because a person in the bus looking at you will go, hang on, wait, they're going behind us now. Okay? But if you're in the car and you look at a lamppost or the traffic light or the stop street, you'll realize that you're not moving. So you're stationary. Why is position important? Because we need it for distance and displacement. So distance is the total path length traveled. Here it goes, we can go up, down, left, right. So somebody goes on a hike, so there's my little person, and they go for a hike and they do all those sort of things, and then they end up here. They maybe walked, say, 7 kilometers. We don't care that they went back on themselves. We don't care if they went up, down, sideways, left, right. They just walked 7 kilometers. So it's the total length of the route. Direction is not important, because distance is a scalar. The symbol is a capital D. The unit is meters. Generally, we work in meters, but there are exceptions. Like here I said kilometers if we're working with really long distances, okay? It's a scalar, which also means you can only get positive you can only get positive distances. You can't have a negative distance because it has no meaning. Displacement, however, is the difference in position. Another way we can say this, no, that's not what I wanted, is we can go, well, actually, if I go back here, my displacement is that. It's a straight line from my beginning to my end. And I'm hoping you've heard the saying as the crow flies. So if someone says it's 2 kilometers away as the crow flies, it means that if you could fly over the buildings, or you didn't have to worry about those, you could hop over the buildings, whatever the case may be, you could go in a straight line. So displacement is a straight line, and it's always from the beginning to the end. Okay? Of the journey, or whatever it is. So, it is the shortest distance between start and end point. Direction, very important. It is a vector. It's measured from start to finish. Must include direction. So your answer must be left, right, up, down, north, south, east, west. Its symbol is now delta x if it's horizontal, delta y if it's vertical. So this is if I throw something. Okay? That we're mainly going to use horizontal. Again, the SI unit is meters. It's a vector, so we can have positive or negative. Positive and negative isn't about size, it's about direction. So, a dog sees a juicy bone behind a tree. He runs, picks up the bone in his mouth, and then goes to his kennel where he can eat the bone in peace. So here's the situation. Okay. The dotted line, so this line here, is the dog's footprint. So this is the path he followed, which was 8 meters. Okay, so it goes around the tree, ends up at his kennel. The distance is 8 meters because we don't care about direction. However, the solid line, that one, is the shortest path. That's only 5 meters. Now, granted, he won't get the bone, but he'll have gone the shortest distance. That straight line is his displacement. But watch, I now have to say that's 5 meters to the right. I have to put to the right here. Example 2. A crow flies 10 kilometers east. Then it flies 6 kilometers west. It obviously doesn't know where it wants to go. First, we want the movement in a diagram. So he goes 10 kilometers east, 6 kilometers west. And as a result, this is his resultant, this part here. Now note, we said R, not F, because it's not a force. Okay, it is not a force. So we use R. Then they want, what distance did the crow fly? Well, he went 10 and then 6, so 16. That's straightforward. I'm keeping it in kilometers because my question was in kilometers. What is the crow's displacement? That's the resultant we have over here, but now we're going to calculate it. I'm taking east as positive, y, because it was the first direction given. So my delta x, because it's horizontal, is plus, because this is when it was going east, plus minus 6, because that's when it was going west. So we get 4 kilometers, but it's a positive value, so it's 4 kilometers east. Soldiers go on a march in the desert. They first walk 6 kilometers west, rest a little bit, then 10 kilometers east, rest a little bit, and then 4 kilometers west. So this is what they did. They start at A, they go west, then they go east, and then they go west again. Okay, let's take some of those up because now it looks terrible. But what I needed you to see is where it starts. Okay, so A, let's change color. That's the starting point. Okay. First question is, what is the distance covered? Well, distance is just adding everything together. So distance is the 6 plus the 4 plus the 10. 20 kilometers. No direction needed because it is distance. Distance is a scalar. Now they want the displacement. So here we've got to make a decision. Now they first went west. So I'm going to take west as positive. Okay. So this is that's when they went west. This is when they went east. That's when they went east. West. So it's plus 6 minus 10 plus 4. And we can see from the diagram that they went nowhere. They ended up where they started. 0 kilometers, no direction. They don't have a displacement. Okay? Now they want their position at the second stop. So second stop, this is stop number 1. That's stop number 2. So they went 6 kilometers west and then 10 kilometers east. So we're still taking west as positive. We can't change our direction, our positive direction. So remember, it went west, then it went east, and now I get a negative number. Minus 4 kilometers, but because it's minus, it means it's 4 kilometers east. We never leave an answer as negative. We change it to positive and give me a direction in words. Okay? You're going to now need to do activity 2 on page 221, questions 2, 4, and 5. You can look on Teams for the answers. And before we'll go to unit 4 in the next video, do not change your direction chosen as positive. Once you choose that in a question, you stay with that, okay? You cannot change the direction you're taking as positive.